The sky starts melting the probe before the surface even appears. Acid streaks crawl sideways across the windows like burning rain, while orange light smears over the metal shell. The deeper the descent continues, the less the atmosphere behaves like air. Sulfuric acid hangs inside the clouds for nearly 40 miles above Venus, thick enough to eat through seals, wiring, and cooling systems while the vehicle is still falling. Clouds are supposed to cool a planet. These clouds trap heat instead. The outer shielding begins blistering almost immediately. Cameras lose clarity behind glowing chemical residue. Somewhere below, the pressure climbs past 90 times Earth's sea level pressure. Long before landing, a human body would already be trapped inside a crushing furnace. Lungs could not expand. Skin would burn inside protective layers. Even breathing systems would start overheating from the air itself. Then the light changes again. The yellow haze darkens into deep orange, and the horizon disappears completely. For a few seconds, there is no clear up or down. The probe keeps falling through moving heat thick enough to shake the hull. NASA missions that entered Venus decades ago survived only minutes near the surface before the planet tore their systems apart. The ground is still invisible. The probe is already failing anyway. The haze finally thins, and the surface appears through the orange glow like metal inside a furnace. Dark volcanic plains stretch beneath the probe in every direction. Rocks cast faint shadows through air so thick the sunlight barely reaches the ground. A lander sits against the black terrain glowing dull red, not from fire, but from the atmosphere itself heating the metal non-stop. The cooling systems stop recovering. Heat pushes inward through the hull faster than machines can force it back out. Lubricants begin breaking apart. Internal wiring cooks inside sealed compartments. A human standing there would not burst into flames. It would feel worse than that. The heat would keep building with nowhere to escape. Breathing systems would recycle hotter and hotter air until the inside of the suit became an oven. And the strangest part is that the sun barely moves. Venus rotates so slowly that one day lasts longer than an entire Venusian year. The night side should cool for months at a time. Instead, temperatures stay near 900 degrees Fahrenheit almost everywhere. Soviet landers recorded the same crushing heat whether sunlight reached the ground or not. The heat never leaves. The atmosphere holds it in place day and night, like the planet sealed itself shut billions of years ago. There is no colder direction to move, no safe shadow. Even in darkness, the rocks stay hot enough to warp metal until structures slowly begin folding under their own weight. Sunlight still reaches the surface. You can see it filtering through the sulfuric haze in pale bands, scattering across the orange air above the volcanic plains. The ground glows back upward through the lower atmosphere, like heat trapped inside dirty glass. For a moment, the system almost looks simple. Light gets in, heat stays there. The planet traps its own heat. Venus is wrapped in carbon dioxide so dense the atmosphere presses against the surface like ocean water nearly a mile underwater on Earth. The sky looks soft enough to walk through, but the air pushes like a crushing liquid. Joints inside a pressure suit would stiffen under the force. Structural frames bend inward constantly. Even standing still becomes mechanical work. And the heat keeps recycling. The lower atmosphere radiates warmth back toward the ground faster than the planet can release it into space. Orange thermal haze pulses over cracked rock, while the surface stays locked near 900 degrees Fahrenheit day and night. NASA measurements confirmed the pressure decades ago, but the visual contradiction still feels wrong. Bright sky above, furnace below. For a few seconds, Venus finally makes sense. Then another problem appears. If the greenhouse effect explains everything, the planet should at least become stable. Instead, the atmosphere keeps moving like something underneath it is still driving the heat harder. A wall of yellow cloud suddenly races across the horizon, fast enough to erase the mountains behind it. But the ground beneath barely moves. The contradiction feels wrong immediately. The volcanic plains sit almost frozen under the orange haze, while the upper atmosphere tears around the entire planet in only a few Earth days. From the surface, the sky would look alive. Massive cloud bands sliding overhead at jet stream speeds, while the rocks below remain trapped in near total stillness. The sky moves faster than the planet. European Space Agency observations later tracked this motion directly, watching the upper atmosphere circle Venus again and again, while the surface turned so slowly it almost disappeared underneath the storm system. The heat is not staying in one place anymore. The atmosphere carries it everywhere. No part of the planet gets time to recover. High above the volcanic plains, heat and corrosive chemicals keep circulating non-stop through the cloud layers, then dropping back toward the ground again. Structures face pressure from every direction at once. External seals burn under acid exposure, while internal systems keep overheating from trapped air that never cools. Even protected machinery loses orientation because the environment itself never settles into a stable cycle. For a moment, the horizon seems to drift sideways. The surface remains still. The clouds keep moving. The entire atmosphere behaves less like weather and more like a machine spreading heat across the planet continuously. There is no safe region hiding on the dark side, no colder hemisphere waiting somewhere beyond the haze. The furnace keeps rotating overhead. A Soviet lander sits silent beneath the orange haze while heat ripples above the rocks around it. For a while, the transmissions continue. Temperature readings, pressure data, static bursts through the atmosphere. Then the signal weakens. Internal electronics begin cooking inside their own insulation. Pressure seals rupture one by one. Cooling systems stop fighting the heat and start absorbing it instead. After minutes, sometimes nearly 2 hours, the landers all disappear into silence. The surface keeps heating them anyway. Venus is hotter than Mercury, even though Mercury sits closer to the Sun. That contradiction only starts making sense once the atmosphere traps heat faster than the planet can release it. The surface no longer cools when sunlight disappears. The heat stays low near the ground instead. And Venus may not have started this way. Some planetary models suggest oceans once existed here billions of years ago. Water could have carried heat upward, formed weather, cooled the surface. But as the planet heated, the oceans disappeared into the atmosphere. Carbon dioxide kept building. The pressure kept rising. The cycle stopped reversing. The volcanic plains remain dim beneath the orange haze, while heat continues moving through the lower atmosphere day and night. Metal weakens slowly. Structures bend inward over time. Even in darkness, the air near the surface stays hot enough to keep damaging anything left exposed. Nothing here cools long enough to recover.